So previously you have worked with me on the reactions of alkali metals with water. This time we have reactions of alkali metals with air. Now we have already discussed they are very reactive and they instantly react with air. We have discussed that when we freshly cut them, they have a very silvery gray shiny appearance. But as soon as some time passes on, they react, and that appearance is completely changed. We use the word tarnish for them, we have used the word before, but now we are going to study this reaction with air in detail. Now, starting off with lithium, sodium, and potassium, they're all stored in oil because they react with oxygen in the air, if I be specific. Now, take out a piece of sodium, take it out of oil. It usually has the crust on outside, this blackish appearance. It is not shiny until it has been freshly cut. Now, when we cut it, the fresh surface is shiny, but it tarnishes, which means it changes its appearance, become the same blackish up top appearance as soon as we cut it, and a few minutes pass on because it's exposed to oxygen in the air. It reacts with oxygen, it forms an oxide, and that's how the whole reaction goes. For this oxide to be formed, we have a general formula of M2O, which means lithium is going to form Li2O, sodium is going to form Na2O, and potassium is going to form K2O. So it's pretty easy to understand what oxide or what formula of oxide they're going to form. However, what we need to understand is that down the series, they get more reactive. So potassium's reaction will be more reactive than sodium. Sodium's reaction is going to be more reactive than lithium. And the speed, the rapidness of the reaction is what we are going to see in them. All right. So
Mhm.
if I move forward and we actually burn them in the air using a Bunsen burner, there is a much more vigorous reaction, of course, and it is more difficult to see which metal is more reactive because the reactions would be rapid, so rapid that we can easily call them instantaneous reactions. The reactions would occur in an instant. You bring them in the flame, the color of the flame changes, and they quickly form those oxides. The temperature pushes the reaction to be extremely fast. So you form that Li2O I was just talking about, or Na2O or K2O, but while forming these oxides, you will change the color of the flame. So if you have the orange or the blue flame, let's suppose you have a blue flame, you have a clean blue flame, it would turn to red or yellow or lilac. Lilac is close to purple. So this is going to be your reaction. You can imitate it. For example, for sodium, this would be 4NaS plus O2 gas, and this is going to give you 2Na2O solid. Now, it's really easy to replace the symbol of the metal with M and get your answer. In each case, you're going to get a white powder. That white powder is the metal oxide. So remember the charge on the oxide ion was O negative 2, the charge on the alkali metal was M positive, so you already know which ions are going to work. A little bit of something different from what we are already done with is that alkali metals react in the air and they form the oxides, but there are other types of oxides that may form. There are peroxides which have this kind of formula, then there are superoxides which have this kind of formula. They all contain the M positive ion, but the oxygen part is different. On the other hand, lithium is the only one that can react with nitrogen with ease and it can form lithium nitride. So apart from simple oxides, you may have other kinds of reactions as well. However, they did not ask you to memorize this part. Usually they give you a hint as they go along, and that hint can work really great in getting your answers right. Now, group 1 metal ions are colorless, which means their compounds are going to be colorless or white. unless they're combined with a colored negative ion. Potassium dichromate is orange because of the negative ion. Dichromate is orange. Potassium manganate is purple because the manganate ion is purple. It's not because of the potassium. Let me tell you, if the sodium salts or the potassium salts, if they don't have a colored negative ion, they tend to go with all colorless salts. So they are typically ionic solids. They are mostly soluble in water. Let me tell you, most salts of potassium and sodium are soluble in water. So if I summarize this, main features, group 1 elements are all metals. They are soft, we can cut them with a knife. They have low melting points, they have low densities. They can be stored in oil out of contact with air or water. Why? Because they react rapidly with air or oxygen in the air to form coatings of metal oxide. We call it tarnishing. This specific reaction is considered as tarnishing, right? The reaction with water produces an alkaline solution, metal hydroxide, hydrogen gas, which may also can catch fire. We watched a very exciting video about it in our last session. The reactivity increases as we go down the group. Usually the metals have plus one ions in which they form compounds. Most of the compounds are colorless, which is given in the next sentence, and they can dissolve in water too to give colorless solution. So if we're done with all alkali metals, starting from lithium all the way to cesium, then I hope if we are done with these, we can move on to predict the properties of francium. Francium is below cesium, francium is radioactive, francium decomposes really easily, so we're not able to study it in that with that ease. So you can go ahead and you can predict the properties. So since we already know when we go from top to bottom, they get more soft. So francium is going to be the softest element on the list. If you go down the group, the melting point decreases. So francium will have the lowest melting point, which would be around room temperature. Francium will melt, probably melt at around room temperature. The density also decreases a little bit. So yeah, the density would be around 2 grams per cubic centimeter. They're all silver gray metals. They tarnish almost instantly in air. So would francium. Francium with the fastest in its reaction, hence the word instantly. It's also going to violently react with water. It's going to give us francium hydroxide and hydrogen. It would be more reactive than cesium. Francium hydroxide would have the formula FrOH. This would be soluble in water. This would give a strongly alkaline solution. This would be a white colorless compound. So we can predict a lot of things about them. All right.
Yeah.
So going in the similar way, we can keep on predicting stuff about francium. A graphical method can be used to predict the melting point. Now, moving on all the way from lithium, sodium, potassium, rubidium, cesium, we can predict francium as well, right? So this
Yeah.
way it comes around here. There you go. We have atomic numbers over here. That's how we understand which one is what. That's how we have quoted the points, right? And there comes francium. So yeah, around 21 or 22, right? Which is
Yeah.
also written over here.
Mhm.
Predictions tell us anything in between 21 and 27. Different numbers to be on the safe side. And this winds up your chapter.